Good morning, dear learners. Today we will learn one of the algorithms which is used in the field of information security. The algorithm is DiffieHellman key exchange algorithm. And information security is protecting the data from damage or unauthorized access. So the objective of data security is to assure that the data is safe, to prevent unauthorized access, and to keep it away from damaging agents. These are the objectives of data security. And this security is implemented through some algorithms. The techniques used to implement data security algorithms are cryptography and steganography. Cryptography refers to conversion of intelligent data into scrambled, unreadable, and meaningless form. So the original data is a meaningful one which is readable, but the converted data is meaningless. The hacker or an unauthorized person cannot read it. If you want to get message from this text, then you have to use decryption algorithm which convert this meaningless code into meaningful form. So the process of converting an intelligent message to unintelligent form is called encryption, and the reverse process called as decryption. And the steganography is the method of hiding data in a covered medium so that nobody else other than the sender and the recipient knows the existence of data in the medium. Today we are going to learn about one of the algorithms which is used in cryptography. So cryptography algorithms are of three types. The first one is secret key cryptography, second is public key cryptography, and third one is hash function. So in secret key cryptography, a single key is used for both encryption and decryption. I said at the sender side, the message to be converted into meaningless form through a process called encryption, and at the receiver side, the meaningless data should be converted into meaningful form by an algorithm called decryption. So all the algorithms involve encryption and decryption process. So in the case of secret key cryptography, both the sender and the receiver use same key, that is single key for encryption and decryption. But whereas in public key cryptography algorithm, the users use two different keys, one for encryption, another for decryption process. And in hash function, it uses mathematical calculations to transform the message from meaningful form to meaningless form. Okay, now today we are going to learn about an algorithm which is used to share the secret key in the case of secret key cryptography. Okay, so as I said already, in the case of secret key cryptography, both encryption and decryption process use same key. So in that situation, the key must be shared secretly between the sender and the receiver. And in the case of public key cryptography, different keys are used, one for encryption, another one for decryption. Two different keys are used. And in the hash function, a mathematical function is used to convert a plain text into ciphertext. Okay. Now we look at the symmetric key cryptography, and the DiffieHellman algorithm is used to share that secret key between the sender and the receiver. Okay, so secret key cryptography uses single key for both encryption and decryption. So this key must be shared between the sender and the receiver. So DiffieHellman algorithm is a public key algorithm which is used to share the secret key between the sender and the receiver in the case of symmetric key cryptography. Okay. So DiffieHellman key exchange algorithm is a simple public key algorithm, and it enables the two users to establish a secret key between them. Okay, now how we are going, the algorithm helps to share the key between sender and receiver in secret can be expressed by means explained by means of an example. Okay, let me assume that the person involved are Alice and Bob. So you want to share a secret key between Alice and Bob. And in this algorithm involves some keys values, common value, that is public value. So let me consider yellow color is known to both the person. Okay, so this is called as public keys or common value. And Alice will choose some other color as his private color, and again B also choose some other color as his private color. Okay, now Alice mix the secret color with the publicly known color and arrive at a new color combination. Similarly, Bob also mix his private key with the known color and he arrive at a new color. So they each one will share the new color they arrive at to the other person. So Alice will share the key to Bob and Bob will share that new color to A. Now with that received value, A add his own private color and arrive at a new color. Similarly, B also mix his own private color with the color received from A and he arrive at the same new color, because this new color are the combination of public color, that is which is known to both Alice and Bob, and A's private key and B's private key. Similarly, this is a combination of public key and A's private key, and with that we are going to add B's private key. So this is also a combination of public color, A's private key and Bob's private key. So both arrive at the same color combination. But if you want to generate this color, new color, one should know the secret key apart from the public color values. Okay. So if the person want to generate this color, so this color is the key color. Okay, this will be used as a key. Both arrive at the same color combination. Okay, so this can be used as a shared key or secret key for encryption as well as decryption. So if a third person want to encrypt or decrypt, then he should know the value of this key, secret key. But if you want to generate this key, the person should know the public color value and the secret color value of Alice and Bob. The secret key color is kept secret by Alice and Bob. Nobody else knows that color. So that involves the security of this algorithm. Okay, so that's an example. Now we'll see the mathematically how we are going to use this DiffieHellman algorithm. So this DiffieHellman algorithm use two numbers as public numbers. They are Q and alpha, where Q is the prime number and alpha is the primitive root of Q. So what do you mean by primitive rooters? So the primitive root of a number P is 1, okay, whose powers modulo P generate all integers from 1 to P minus 1. That is, A may be considered as a primitive root if A mod P, that is A power here is 1, A power 1 mod P, A power 2 mod P, A power 3 mod P. Each term will give you a unique value in the range 1 to P minus 1 with in some permutation. In that situation, A will be considered as a primitive root. Okay, so for each value, you will have one integer called B, and B range from 1 to P minus 1. Okay, for any integer B, the primitive root A of a prime number P, we can find a unique value I such that B is equal to A power I mod P. What do you mean by this is, no two values of I will give you same B value. Even it is a modulus value, no two values of I will give you a value equal to B. Okay. So I is a unique value for each value of B. So the exponent I is referred to as the discrete logarithm of B, and this I can be calculated as I is equal to discrete logarithm to the base B of B. So I will be considered as a unique value. Okay, now we come back to DiffieHellman algorithm. Here we are going to make use of public keys q and alpha. As I said already, q is a prime number and alpha is the primitive root of the prime number q. Okay. Now, suppose A and B wish to exchange a key. A choose one random integer xa such that xa value is less than q. Okay, he can choose any value from 1 to q minus 1. So q is a prime number. Okay, 1 to q minus 1, and he keep that as secret. So this is similar to your I value. Okay, using that he will find one integer ya by using this formula. Ya is equal to alpha for xa mod q. Xa is the secret value of a user A. Similarly, user B select another random integer xb which is also less than the prime number q, and he calculates another value yb is equal to alpha power xb mod q. Q is the prime number, the alpha is nothing but the primitive root of q, and using that he will find out yb. Okay, as I said already, no two xa value will give you a same ya. Similarly, no two xb will give you same yb value. For each and every xa value, ya is unique. Okay. Now, they are going to share the values they arrive at. So, the person A or user A will share the value ya to B, and person B share yb to A. Okay. And using that value they received from the other one, each one calculate the secret key k. So user A computes the secret key k by making use of value of yb which is sent by user B, and his own private key xa as k is equal to yb to the power xa mod q. Similarly, user B also calculates the same key value k is equal to ya raised to the power xb mod q. Okay, and both will arrive at same value of k, which will be used as a secret key for encryption and decryption. So this is how they both arrive at same value. K is equal to yb for xa mod q, and by doing some procedure, we will arrive at the value that is equal to ya for xb mod q. So this is the value calculated by B, and this is the value calculated by A. So both are same. And this key k can be used as a secret key for both encryption and decryption. Okay, so this is a diagrammatic representation of this algorithm. Okay, now what the security involved in this is, okay, now consider if an adversary, that is a hacker, want to hack the image message, then he should know the value of the secret key k. K is nothing but k is equal to alpha. Okay, you can calculate the value of k like this, ya per xb mod q. If you want to find the value of k, he should know the secret value xb. So the xb can be calculated by two methods. One is either by discrete logarithm method or brute force attack. So the first one is called this discrete logarithm method. In this method, he can calculate the value of xb as xb is equal to d discrete logarithm of alpha q to the value of yb. The user know all these values. Alpha is known, q is known to him, and yb is also known. Even though he know all these three values, it is very difficult to find the value of xb because discrete logarithm is very difficult. To calculate the value using discrete logarithm is very difficult. So for large prime numbers, if the number q is a prime number, if it is a large one, then it is impossible to calculate the value of k. Similarly, the other method is brute force attack method. Here also, he can try with different values of xb to arrive at the value yb. But that again, if the prime number q is a larger one, then the xb range from 1 to q minus 1. Here again, it is very difficult to find the value of xb.